Hey everyone, here's the now question from 2022 AMC 10A. Okay, this is the number 10, and we have just a geometry problem right here. So it says Daniel has a rectangular index card, and the diagonal is 8, so that's right here. And then he cuts this like two squares from each corner, like that is the unit square, so one right here, one right there, and you measure the distance between those two closest vertices, like this point and this point, that is 4√2. Okay, that's given. So what is the area of the original index card? Okay, so if you are looking for the original index card, which is actually a hint for us to complete our diagram, because we are going to find the area of this whole region. So I'm going to go ahead and complete this. And if I do this, so I will have something like this, right? And I will say, let me take this guy back. Okay. So the area of the original one is going to look like this. Okay, so let me connect those. So this is the area. I'm going to say, if I call this is X, and this is maybe the Y, right? And we are looking for X times Y. So that is what we want. So it's good to write what we are trying to achieve, so we know what we are looking. Otherwise, like we may try finding X and Y separately, which may be a bit challenging. Maybe it's not what we really needed. So we just need the product of those two X and Y. Okay. So we know this is 1 unit, this is 1 unit. So, and then we have this 4√2, which looks like I probably wanna make a right triangle, so I can actually use that given information. So if I extend this all the way to this side, and then if I do the same thing, so I can make a right triangle. Okay, so the right here, so we have a 90 degrees. So I have this guy is going to be long leg, this guy is another leg. Since we know this is 1 unit, we are cutting 1 right here. So that means this distance, which is the length of this triangle, has to be X minus 2. Okay, so I'm going to write it right here. So the X minus 2. And the same thing, like this whole length was Y, and then since we cut 1 unit right here, 1 unit right there, so this piece has to be Y minus 2. Okay, so now I can use my Pythagorean in this right angle triangle. Okay, so if I do so, that should be X minus Y, right? So the X minus Y, I mean X minus 2 actually. X minus 2. And then I have, this is X minus 2, and this is Y minus 2. So then Y minus 2. And that is equal to the square of the hypotenuse. 4√2 square will be 32. Okay. So if you expand this, we will get a quadratic with 2 unknowns, right? Which is actually gonna help, but we just need another information to solve this, maybe the equation. But at the same time, this information, which is diagonal of the larger rectangle, that was also given, right? So I can remember, like that's also another right triangle right here, so I can use the Pythagorean in the larger one. So that is actually X squared. Okay, so that's X squared plus Y squared is equal to 8 squared, which is 64. So because that's the diagonal of the rectangle, which is a square, I mean a right triangle right here. Okay, so we have now these two. Maybe I can use both of these to get what I want. So if I expand this one, you can just use binomial, the X squared minus 4X and plus 4. And then this guy will be Y squared minus 4Y and plus 4. That should be 32. Again, it just like the square of binomial right here, or you can just multiply x minus 2 by x minus 2 to get those. So, and I do know this guy and this guy is add up to 64. So I can replace with that. So that should be 64. And then minus 4x minus 4y. So I can take minus 4. So that should be x plus y. And then I have 4 plus 4, which is 8. And that is 32. Okay, so now if I find this x plus y from this equation, subtract 32, that will be 32 plus this 40. And if you move this guy, so they will get 4 times x plus y is 40, x plus y is 10. Okay, so that's something. So we know x plus y is 10, but that's not what we wanted. We are looking for x times y, and then at the same time, we know x squared, y squared. So if I square this guy, okay, so actually we are gonna get something really nicer. So if I square this one, so that will be x squared plus 2xy plus y squared is equal to 100. Okay, so and I do know x squared, y squared is 64. So this guy plus this guy is 64. So if you subtract from both sides, so you get 2xy. 100 minus 64 is just 36, and then xy will be 18. So this is actually what they were asking, because they are asking the area of the original rectangle, which is actually the answer B. Okay, so I hope that makes sense. That was number 10.